Alright, welcome back to 1720. We are in Chapter 6 doing Section 2. This is the last section we're going to go through in Chapter 6. But it's essentially us solving trig equations, just like we would an algebra equation or things like that. So we're going to go through these different methods here, doing linear, zero factor, quadratic methods, substitution, things like that. So, just like we did in algebra where we solve equations for the missing variable, we are going to solve trig functions for the trig function, okay, that's in question. Alright, so let's take a look at this. We have this equation here, 2 sine of theta plus 1 is equal to 0. I want you to think of this as just like doing 2x plus 1 equals 0 in this scenario. So very simple, we want to solve it from 0 to 360, so we're looking for all the answers in this. So please remember that there are multiple answers because all students take calculus. And you might have a positive answer occur in 2 different quadrants. So think of this as 2x plus 1, but it's really just 2 sine theta plus 1. Doing the same kind of math operations. Undoing addition and subtraction, undoing multiplication and division. So rewrite this, okay? And add or subtract 1 to both sides. So you're going to get 2 sine of theta equals 1. And then we're going to divide both sides by 2. Alright, so we're going to get sine of theta is equal to 1/2, just like you would have if it was 2x plus 1, x would have equaled negative 1/2. So we got to think, when is it negative, right? All students take calculus. Sine is positive in the first and second quadrant and negative in the third and fourth quadrant. So when we draw our triangles, okay, if you need to, still using that method, all right, you will draw your triangles in the third and the fourth quadrant. Or we can also note, all right, we got 30 degrees, so I know my 30, 60, 90 triangle because we know that 30 degrees equals the 1/2. So remember, that's a 1 square root of 3, 2 triangle. So if you know your triangle is good enough by now, which hopefully you should, we've been working on for 6 chapters, you can automatically kind of go here. Else you have to draw your triangles and get your values that you want to. So we know that 30 is going to be our reference angle. So if we draw both of those triangles out in the third and the fourth quadrant, okay, we're able to see where the 30 degrees comes from, and that we already know off of our unit circle, all right, that the x value is negative square root of 3 over 2, the y value is negative 1/2. All right, that's what we should know, right? That's our cosine value and our sine value. So we should know the answer is going to be what? When we get into the third quadrant, okay, 30 degrees is the reference angle, but that angle is really what? 210, right? It's 180 degrees plus 30, which is 210. If we're in the fourth quadrant, we know the reference angle is 30. It's 360 minus 30, which is 330. So that kind of stems back to Chapter 2 stuff as far as this goes. The meat and potatoes on this one is being able to solve the trig function, finding the values, all right? That's stuff that we've been doing all year long. That should be kind of second nature to you guys when you do that. All right, so make sure on your homework assignment that you choose both angles in there that it asks for. Okay, so if we want all solution sets, all right, we have to deem it in terms of 360n, right? And to each one of these, because remember, I can go around another 360, 360, 360. So we're going to take 210 degrees, that's the first solution set, plus 360n. That covers every possible scenario. Same with the 330 plus 360 times n. All right, that covers every scenario for that version. Okay, because if it's a circular function, so it's going to be able to keep going around and around and around, we will have infinite number of solutions there. All right, so let's take a look at this one now. We have sine of theta tangent of theta is equal to sine of theta. All right, the one thing I want you to think about on this one is be careful here. I know that it's like, hey, we can just divide both sides by sine, and then we get tangent of theta equals 1. The problem is when you do that, we only get one solution that we're looking for. So be very careful on these problems. You actually have to do a little bit more work. Don't simplify right away. So this is the zero factor property. So this is where we take our equation and set it equal to 0 and solve. So in algebra, right, we set everything, the equation equals 0 and solve for x. We're going to do the same thing here. So this is called the zero factor property. So when we do this one, we're going to take sine theta tangent theta equals sine theta. We're going to move the sine that's on the right hand side over. All right, so we're going to subtract it from both sides. So we're going to end up with sine of theta, tangent of theta, minus sine of theta equals 0. Now, this is where we factor out sine. So we got to know our factoring skills. We're going to factor sine out. When we rewrite that, we're going to have sine of theta times tangent of theta minus 1. So we've factored sine of theta out. Now this goes back to algebra. We take both parts and set them equal to 0. So you're going to take sine of theta and set it equal to 0 and solve. And you're going to take tangent of theta minus 1 and set it equal to 0 and solve. This would be no different, guys, if we had like x times x minus 1. Right? We set each part equal to 0 and solve for the value. So setting each one equal to 0, sine of 0, all right, we know that that's what? 0 and it's what? Pi. So sine of 0, sine of pi, or n pi, right, for all solutions would work on this one. The tangent of theta minus 1 equals 0, right? We have to add 1 to both sides. So we're looking for when tangent of theta is equal to 1. Well, all students take calculus. That happens in 2 quadrants, right? We know that tangent of theta equals 1. That's a 45, 45, 90 triangle, right? Because it's a 1, 1 square root of 2 triangle, right? And theta is opposite over adjacent, so it's 1 over 1, which is 1. So we know in that solution that it's 45 degrees. And then we know that tangent's also positive in the 3rd quadrant, so you have to take 180 plus 45 degrees. All right, so we got to think about this. This one has multiple answers. So the sine gives us 0 and 180, or 0 and pi, right? And then the tangent gives us 45, or pi over 4, okay, or 225, right? That's the 180 plus 45, or you would take pi plus pi over 4, okay, and you'd get 5 pi over 4 for that one. Okay, so that's our solution sets. So that's just the caution that I told you about, making sure if we didn't do it right that we wouldn't get all the solutions. Okay. All right, let's take a look at this one. A zero factor property. This is a quadratic, right? I want you to look at this and you should recognize that this might be what? An x squared plus x minus 2. So kind of think of them, because if you can do the algebra, you know, and it's easier for you to put it in terms of x and solve it that way, you can. All right, but I want you to see that this is a quadratic expression. So it's tangent squared of x plus tangent of x minus 2. All right, we want to solve it over the interval 0 to 2 pi, so we know our answers need to be in radians in this scenario. Okay, so the first step, right, setting it equal to 0, factor this. All right, this should become 2 different binomials. So we can factor this in. Like I said, treat it like x squared plus x minus 2. That you know that would factor into x minus 1 times x plus 2. So in this case, tangent squared of x plus tangent x minus 2 factors into tangent of x minus 1 times tangent of x plus 2. All right, now we solve both of these individually. So we're going to take tangent of x minus 1 and set it equal to 0 and solve, and tangent of x plus 2 and set it equal to 0 and solve. All right, so we get tangent of x equals 1, or tangent of x equals negative 2. So we have to do our solutions just like we did before. So we know the first one, just from the previous one, is a 45 degree angle, pi over 4. And then it's also happening in what quadrant? The 3rd quadrant. So that's 180 plus the 45, or pi plus pi over 4, which gives us the 5 pi over 4. So the pi over 4 and 5 pi over 4 for tangent of x equals 1. Those are our first and our 3rd quadrant solutions. Okay. The other one, okay, has to end up where it's negative. So this is a 2nd and a 4th quadrant solution when we do this. So you're going to have to take like pi minus pi over 4, or sorry, we have it's negative 2 on this one. So when we do that, you're going to use your calculator to get the approximated values on that one, because it's not a nice answer that's easy to do in your head. Okay, so these 2 answers, you're going to use your calculator. Right, so you're going to do 2nd tangent on your calculator, which gives you tangent inverse of negative 2. So this is everything that we just kind of learned in the last section of this chapter. So you're going to hit 2nd tangent and then type in negative 2. Make sure you're using negative and not the minus sign on your calculator. So you should get negative 1.10, and then do the same thing for the other possible solution here. All right, those are the reference angles. You should be able to get those, okay? just drawing out where they are, adding, subtracting from pi, all right, and then 2 pi. And that's where those values come from, okay? So we should get the solution set on the left, the pi over 4, 5 pi over 4. That came from the tangent of theta equals 1. And then the 2.0344 and the 5.176, those come from the tangent of theta equals -2, okay? So just to reiterate, we get that -1.107, and we have to subtract that one from pi, or add it to pi since it's negative, I guess you want to say, and then we have to take the other one and add it to 2 pi so that we end up in the quadrants correctly. So remember that -1.017, that's not our solution. That's how we get to our solutions. Our actual solutions are 2.0344, okay, and 5.17. All right, let's do another example here. We're solving a trig equation using the quadratic formula. All right, everybody's favorite. -b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So hopefully remember those, and the coefficients in front of that. So right, we have ax squared plus bx plus c. All right, those are where we get the values, the coefficients in front of all the functions. Okay, so in this one, how do we know to use the quadratic? Well, you're going to kind of see that it's not really a nice way to factor this. All right, so when we rewrite this, we're going to distribute the cotangent through, and then we're going to subtract 1. All right, so cotangent times cotangent gives us cotangent squared, and then cotangent times 3 gives us 3 cotangent of x, and then we subtract 1 over. So we're in a quadratic form, right? We have like an x squared plus 3x minus 1, if you're thinking of it in algebraic terms. Now this one doesn't factor nicely, so we can use the quadratic formula, okay? Notice the coefficient in front of cotangent squared is a 1. The coefficient in front of cotangent is 3, and c is our -1. So a is 1, b is 3, c is -1. All right, and we treat cotangent like x. So then you just substitute into the quadratic formula once again. -b divided by 2a plus or minus the square root of b squared minus 4ac all over 2a. Google it if you need to, all right? But here's it substituting in, and then we just calculate the values. I'm not going to walk through the algebra on this one. You should know how to do this. You've been doing it in algebra for a few years now. Should be fairly simple for you guys to plug in. When we get that out, remember there's always two values that come out of this. There's -3 plus or minus the square root of 13 over 2. Remember that can be written as two different things. It can be written as -3 plus square root of 13 over 2, or it can be written as -3 minus square root of 13 over 2. All right, those would be our two answers, making sure that they fit our solution set when we go through this, okay? And you can plug them into your calculator, get those approximate values, and remember to get them, we have to do 1 divided by that, because we don't have the cotangent inverse button in our calculator. All right, so we've taken the values on the previous one, all right, and we've put it in the calculator to get the decimal approximation, okay, and then we go with the decimal approximation. We want to find the actual angle. Remember, we're looking for the angle here. We can't do cotangent, so we have to put it in our form to do tangent. And then remember the -1 we have to add pi to, so that we're in the right quadrant. So make sure that you're putting these in your calculator correctly to get the values for x. So you should get 2.84 and 1.27 when you do this problem. Okay. All right, if we wanted to find the solution for any one of them, we would just add n pi because it's tangent, and remember it has to do with the sine over cosine, and when cosine is going to 0. All right, let's solve this one, okay, by squaring both sides. All right, let's see what happens here. So we have tangent of x plus square root of 3 is equal to secant of x over the interval 0 to 2 pi. So we're looking for our solution to be in radians again. All right, so in this scenario, you know how do we do that? Well, there's an identity that might help us out or something like that when we look at these sort of things, all right? So let's start by squaring both sides and see what happens here. So I'm going to take tangent of x plus 3, quantity squared. I'm going to take secant of x squared. Why do we maybe want to do this method? Because we have two different trig functions interacting here. Notice all the other examples we've done have stuck with one specific trig function. All right, this has two trig functions involved in it. It has a tangent and a secant. Everything else before only had one. So this is a method that you might want to do when we have two different trig functions involved here. So when we square the left side, remember those are two binomials. So you still have to FOIL or do binomial multiplication in the box method. All right, so when we square the left-hand side, we end up with tangent squared x plus 2 square root of tangent x plus 3 is equal to secant squared of x. So we squared both sides. The right-hand side we replaced with the Pythagorean identity. So we couldn't do that in the beginning because there was no squares. But now that we have secant squared, all right, that's right off your trig identity sheet, right? Tangent squared plus 1 is equal to secant squared theta. So we're able to substitute that. Why did we want to do that? So our equation is all in terms of tangent. Now it's all in terms of one trig function. It's kind of like, you know, we got to get everything all in terms of one variable, like x or y or things like that. All right, so now we solve and set it equal to 0. Okay, so we have tangent square root of x. So we subtract the tangent squared to both sides. The tangent squareds go away. And then we subtract 1. All right, or actually we're subtracting 3 to get into that side. We're solving for tangent of x. And literally we just solve this algebraically. Okay? And simplify and go through there. You should know the algebra behind this. The part that you had to see was, all right, we have two different trig functions. How are we going to get through this? Solve by the squaring both sides method. Okay? Remember, there's two possible solutions where that happen over the interval 0 to 2 pi. So make sure that you're finding both of those solutions. All right? All students take calculus. So since it came out to negative square root of 3 over 3, we should be looking for when tangent is negative, which happens in the second quadrant and happens in the fourth quadrant. So you need to do both of those, whether you draw out your triangles or whether you use a trig identity to solve for those. That's fine as well. But remember, that's all stuff we've been doing since chapter 1. All right. So I'm just going to go through that. There's the work in case you want to see it. Okay. But I'm not going to talk you through the algebra on that one. You should know. Alright, so this is where you might want to pause the video. Just kind of read through these. I'm not going to read them out loud to you verbatim. You can read them. It's just, you know, deciding which method to determine how you want to solve it, or which method you want to use when you solve it. Okay, so you can pause both of these, read through them, write them down, see what's going to help with you. Alright, let's get to our real-world application. We have a basic component of music. It's a pure tone. Alright, the graph below models a sinusoidal pressure P in pounds per square foot of a pure tone at time x equals t, right? So like you hit the key on a piano, you strum a guitar, things like that. You want to hear the actual tone of the frequency of the note, okay? So y equals 0.004 sine 300 pi x, okay? That's the equation that we're going to roll with on this one, for our example. So the frequency of the pure tone is offered measured in hertz, all right? So 1 hertz is equal to 1 cycle per second. We've talked about that before in class, and we abbreviated as hertz. We did this when we were graphing as well, right? What's the frequency of f in hertz of the pure tone shown below? Okay, so hopefully remember where the frequency is. Remember, that's how fast it's going to oscillate here. So from the graph, we can see there are 6 cycles in 0.04 seconds. All right, so we can count all of those in 0.04. So just count the amplitudes if you want, or the maximums. You can see that there is 6 there in 0.04. Remember, it's always how many happen in a specific amount of time. Okay, so right now we're getting 150 cycles per second. Cycles per second, that's kind of the definition of hertz. So we can say that this tone is 150 hertz. Okay? And use the 2 pi over b method, all right, to get the period, and then period is 1 over the frequency. If we look at this, right, remember b up here is the 300 pi. So if I take 2 pi over b, or 2 pi over 300, the pi's cancel, all right, and I get 2 over 300, which becomes 1 divided by 150. That's the period, and the frequency is the inverse of this, so it becomes 150 over 1. So that's the frequency. So remember, we did that back in like chapter 4 when we did our graphing. You should be able to recognize it from there as well. So that's another method to get that. All right. So that's another way. Or, you know, and I just kind of went through how to get the period the old way. Now if we get the period doing this way, all right, we know since it's covers it in 0.04 seconds, the period is going to be 0.04 divided by 6, right? That's how many times it happens, which is 1 over 150. Or, right, we take the reciprocal of the frequency. The frequency was 150 hertz. Remember, the period is 1 over the frequency, or frequency is 1 over period. So they're inverses of each other in this case. So the period is 1 over 150. Okay? So an equation for the graph of y equals 0.004 sine 300 pi x. We're going to use a calculator to estimate it. All right, what are we looking for that make y equal 0.004? All right, and that's the maximum piece, right? Remember that 0.004, if you remember on the graph, that is the amplitude of our function here. Calculator and find all the solutions to this equation here. So when you use the intersect command, all right, on your calculator, you're going to have to do like the left hand side and the right hand side, and then an approximation, and then it'll let you intersect. So notice it's one of the upper commands up above. You're going to have to hit second and so or one of the Y's. You'll see intersect, and it'll calculate it for you, but you have to put the equation in the graph. So for this, since we have a pi, make sure that the mode on your calculator is radians. Okay, and then you put this into Y1, hit zoom 7 so that you're in a trig mode, and then change your window. Your window should match this one. So if you hit window on your calculator, your x minimum should be 0, your x maximum should be 0.02, your y minimum should be negative 0.007, your y maximum should be 0.007, and then you hit graph. You should be able to see this. Okay, under Y2, you can put 0.004 so that you can see the amplitude, and you're going to need that so that you can do the intersection command on your calculator. All right, so when you use the intersection command, you're going to find all the places where that 0.004 occurs. Okay, now I'll walk you guys through this in class, but you should be able to do that and get 0.0017 for the first intersection. Okay, 0.0083 and 0.015. Make sure if you're doing this at home that you can get those values and use the intersection command correctly on your calculator. Okay, so those are all the solutions over the interval that make the maximum happen. Okay, so it's what makes it happen at 0.004. So we're looking for the x values that you would substitute into the equation where that tone is 0.004. Alright, well that is the end of Chapter 6, Section 2. That's the end of Chapter 6 for us. That's all we're going to cover in Chapter 6. We're going to step into Chapter 7 here next. So once again, as usual, email me with any questions or have questions ready in class when you need me to go over some problems. Alright guys, have a great day. We'll see you soon.